In this video, we will be talking about alkyl halides, which are also known as haloalkanes. Firstly, we will learn how to draw and represent chemical formulas and structural and line diagrams of alkyl halides. Secondly, we will learn how to name compounds using IUPAC rules. Then, you will learn types of reactions, and lastly, how to describe physical properties. So to start off, alkyl halides are made up of a carbon chain and halogen, or multiple halogens. Halogens are basically contained in the group 7 of the periodic table. They include iodine, bromine, chlorine, and fluorine. There are 3 types of alkyl halides: primary, secondary, and tertiary. Primary alkyl halides are basically when the carbon that the halogen is attached to is also attached to one other carbon. Secondary alkyl halides are basically when the carbon that the halogen is attached to 2 other carbons. And tertiary alkyl halides are basically when the carbon that the halogen is attached to is also attached to 3 other carbons. There are 3 types of ways to represent alkyl halides. So there's condensed structural, complete structural, and line structural. So for example, if we were given 2-chlorobutane, the first way to do it would be complete structural. So what would happen here is, because it says butane, that means there's a 4-carbon chain. So first you draw out your 4 carbons. Then you'd have to pay attention to the fact that it says 2 and chloro. So that means the chlorine atom is going to be on the 2nd carbon. So you would number them in its lowest terms. So 1, 2, and that's why the 2nd carbon would have the chlorine, and the rest of them you would all label as hydrogens. The second way to do it is line structural, which basically is seen over here. So it's like, again, 2-chlorobutane. So it's going to be like there's 1, 2, 3, and 4. So that's the 4 carbons in our chain. And then again, it's 2-chlorobutane. So you'd number them this way. So 1, 2, 3, 4. So that the chlorine could get the lowest address, which is why this would also represent 2-chlorobutane. The third way to do it is condensed structural, which is basically by writing the carbon chain with its hydrogens. So this is H3C, which is the first one here if you look at it, because there's 3 hydrogens and a carbon. Then you connect it to its CH2, because the 2nd carbon is connected to 2 hydrogens. The carbon here is only attached to 1 hydrogen because the other one is going to be a chlorine. And the last one is CH3 because the carbon is attached to 3. However, when you number it, you'd number it going this way from 1, 2, 3, 4, so that chlorine can be given the lowest address. All of these structural diagrams are going to represent 2-chlorobutane. So if we were given 1-iodo-2,2-difluorohexane, we could write the structural diagram with the help of the name. So basically, using hexane, you know it's a 6-carbon chain, a single bonded 6-carbon chain. And then you take 1-iodo, which would tell you that the first carbon, so first you'd number them before you do that. And so the iodine would be located on the 1st carbon. And then it says 2,2-difluoro, which means there's going to be 2 fluorines on the 2nd carbon. And the rest of the blank spaces are going to be filled by hydrogen. So the rules of nomenclature would help us name the alkyl halides. So first you identify the parent chain and give lowest address to the halogen. You would then name the halogen along with which numbered carbon it is on. And of course you would also name other functional groups if it's required. You would drop the "ide" ending and add a "o", so chloride would become chloro, and then you would name the alkane. Using the IUPAC rules, we can name our alkyl halides. So in the first compound, first we'd identify our parent chain, which is this chain right here. It has 5 carbons. Then what we would do is we would identify which carbon the bromine is attached to, because that bromine is our halogen. So it's on the 1st carbon, and there's 2 of them. So you do 1, 1, and because there's 2 bromines, it would be di. Then, since our halogen is bromine, you drop the "ide" in bromide and you change it to O, so it would be dibromo. And then you would name your alkane, which is, because it's a 5-carbon chain, it would be pentane. So the first compound is 1,1-dibromopentane. In our second compound, we're also going to first identify our parent chain, which is here. So it's 1, 2, and 3 carbons. And so basically what we're going to do is we're going to identify where our chlorine is. It's on the 2nd carbon. So you'd write 2, And because chlorine is it would actually be named chloride, so you drop the IDE ending and you'd make it chloro. So it'd be chloro. In this case, what happens is there's no alkane because we have an alcohol, which is an OH on the first carbon. So instead of it being propane, it would be propanol because we have a alcohol on the first carbon. So it would be 1 propanol. So types of reactions with alkyl halides. So the first kind of reaction we're going to do is the addition reaction. So for example, if we had propene plus bromine, we would get 1,2-dibromopropane. So this would basically be because in the reaction, the double bond would break apart. So it would be a carbon chain with 3 single bonds. You'd still have the H's, which are the hydrogens. However, now because the double bond is broken, the carbon would need 2 more atoms in order for it to be stable. So you'd take the bromine and you would add it into the empty spots. And this would give you 1,2-dibromopropane. The second type of reaction that I'll talk about is the elimination reaction. So for example, if we had 2,3-dichlorobutane, then we would have a product of butene plus chlorine. This would be because first what would happen is you'd still have all of your carbons. And so basically what would happen is because in the elimination reaction, we're going to add a catalyst, which is our H2SO4. And what that would do is speed up our reaction, obviously, and our chlorines would disappear from here. So basically what would happen here is you still have your H's. However, because we lost the 2 chlorines here, there would be a double bond between the 2 carbons for it to be stable. So therefore, this would give us a product of the which is butene. And then also because we lost 2 Cl's, it would go plus Cl2. So our products would be butene and chlorine. The last type of reaction we're going to talk about for alkyl halides is a substitution reaction. So for example, if we were to do a substitution reaction with water, so if we had a compound which is 2-bromopropane and we added water to it, then we would produce 2-propanol, because what would happen is the O and the H from the H2O would replace the bromine and you would be left with HBr, so your products would be 2-propanol and hydrobromic acid. Secondly, for our second example, if you were to do it with ammonia, then your substitution reaction would look something like this. You would have 2-bromopropane plus NH3, and that would give you 2-propanamine, because basically what happens here is your bromine is going to be substituted with your NH2 and you are going to be left with 1 hydrogen and the bromine that was substituted. So then your products would be 2-propanamine and hydrobromic acid. Lastly, we'll be talking about the physical properties of alkyl halides. So alkyl halides are liquid and colorless at room temperature, they're slightly soluble in water, and their boiling point is higher than that of an alkane. This is simply because they have increased polarity, stronger intermolecular forces that are at work, and the molecular size or weight of the compound is also increased. So now that we have come to the end of our lesson, I would like you guys to try some examples. First, you could draw these 2 compounds, then name these 2 compounds using the IUPAC rules, and lastly answer this question which says which has a higher boiling point, 1-butene or 1-chlorobutane. Thank you for listening to this video.